Welcome to Session 1 of GED Geometry, Angles, Lines, and Triangles. I'm really glad you're here. Before we can solve a single angle problem, we need to learn the language of geometry, the words and symbols that every question on the test will use. In this lesson, we'll meet the 5 building blocks of geometry: the point, the line, the segment, the ray, and the angle. Then we'll learn to read the symbols that name them, and the 3 benchmark angles you'll come back to again and again. Let's start with the 4 basic pieces. First, a point. A point simply marks a single location, and it has no size at all. We just draw a dot and label it with a capital letter. Next, a line. A line is perfectly straight and runs forever in both directions, so we draw an arrowhead on each end to show it never stops. A line segment is the part of a line between 2 endpoints. It has a definite start and a definite finish, marked by a dot at each end. And finally, a ray. A ray starts at one endpoint and shoots off forever in a single direction, so it has an arrowhead on only one side. A flashlight beam is a good picture of a ray. Now, the star of the whole course, the angle. An angle is formed when 2 rays share the same endpoint. That shared endpoint has a special name. It's called the vertex. We usually name an angle with 3 letters, like angle ABC. And here is the golden rule you must remember. The middle letter is always the vertex. So in angle ABC, the vertex is B. This matters a lot later, when several angles meet at the same point, and you need to say exactly which one you mean. Each of these objects has its own symbol, and reading them correctly is half the battle. A bar over AB means the segment from A to B. A double-headed arrow over AB means the full line through A and B. A single arrow over AB means the ray that starts at A and passes through B. And the little corner symbol in front of ABC means the angle with vertex B. When you see these on the test, translate the symbol into a picture in your mind. For a ray, the order of the letters actually matters. Let me show you why. Imagine a sidewalk that begins at point P and then continues past point Q without ending. That is ray PQ. The first letter, P, is the endpoint where it starts, and the second letter, Q, simply tells you which direction it heads. If instead the sidewalk stopped at both P and Q, it would no longer be a ray. It would be segment PQ. Angles are measured in units called degrees. 3 benchmark values will guide almost everything we do in this course, so let's lock them in now. First, a square corner. That's 90 degrees, and we call it a right angle. We always mark it with a small square in the corner. Second, a straight line. Open an angle all the way flat, and you get 180 degrees. And third, one complete turn, all the way around a point, is 360 degrees. 90, 180, 360. Keep those 3 numbers close. 2 special relationships between lines come up again and again on the GED. When 2 lines cross at a 90-degree angle, we say they are perpendicular. Think of the corner of a book or the corner of a window, a clean square corner. When 2 lines never cross, staying exactly the same distance apart forever, we say they are parallel. Think of railroad tracks running side by side. We show parallel lines with matching little arrow marks, so you can spot them at a glance. Here's a familiar example that ties it together: a clock. At 3 o'clock, the hour hand points right and the minute hand points straight up. Together they form a 90-degree right angle. Now watch as the hour hand sweeps down towards 6 o'clock. The 2 hands open up until they form a straight line, 180 degrees. You already read angles every day without realizing it. Now, let's talk about the most common beginner mistake, so you never fall for it. Students often assume that a bigger drawing means a bigger angle. Look carefully at these 2 angles. The one on the left has short rays. The one on the right has long rays. But the opening between the rays is exactly the same, so the angles are equal. An angle measures the amount of turn between the 2 rays, not how long the rays happen to be drawn. This is also why the GED warns that figures may not be drawn to scale. Trust the numbers and the markings, not how the picture looks. One last habit that will serve you well. When a problem gives you no diagram, draw your own. Mark each point with a dot, put arrowheads on any lines or rays, and draw a small square at every right angle. Your sketch does not need to be perfectly to scale. Its only job is to show which objects meet and which facts you already know. A quick, clear sketch turns a confusing word problem into something you can actually solve. Let's check your understanding with a quick question. What do we call two lines that cross at a 90-degree angle? Take a second to think. That's right, they're perpendicular. They meet at a square corner, which is a right angle. Let's recap what we learned today. A point is a single location. A line runs forever in both directions. A segment has two endpoints, and a ray has just one. An angle is two rays meeting at a shared vertex. And remember, the middle letter always names that vertex. And keep your three benchmark angles handy. 90 degrees for a right angle, 180 for a straight line, and 360 for a full turn. Really nice work, finishing session 1. You now speak the basic language of geometry, and everything from here builds on it. In the next session, we'll use these ideas to classify every type of angle: acute, right, obtuse, and more. Practice naming a few points, lines, and angles on your own, and I'll see you there.